When you're asked to find the domain of a function given its graph, what you're really being asked to do is list all of the possible x values from the smallest one to the largest one. So we talk from the smallest to the largest. Smaller x values are to the left over here, and larger x values are to the right over here. So we always want to look from left to right when we do this. So in this case, we're looking at a graph that has arrows on both ends, but particularly to start with, as an arrow pointing to the left. It's going down and to the left. Now, the fact that it's going down doesn't really matter for the domain. What matters is that it's going towards the left. So if it's going to go forever to the left, there is not going to be a smallest x value. What we say is that it's going towards negative infinity. And as we've done with interval notation before, anytime you use an infinity, you're always going to use a parenthesis. Then, as we look along the line that's drawn, there are no gaps, there's no breaks in the line, nothing that we would call a discontinuity, right? Nowhere where it stops and then jumps somewhere else. Right? It's just continuous all the way along this line. Right? And then on the right-hand side of our graph, we have another arrow, which indicates that it goes forever to the right. Well, forever to the right means there's no largest x value, so it should just be negative infinity to infinity. For this one, as we look at the x values from left to right, we should see that the furthest left this goes is at this endpoint right here, where x is negative 6. Make sure you use the x value, the value on the x-axis, not the value on the y-axis. We don't want to use any y values when we're talking about domain, just x values. So since this value at negative 6 is where it ends, that's the furthest left we go, so we'll use a negative 6. And then because it's a closed endpoint, meaning that we have a filled-in circle there, right? It's a filled-in circle there. Sometimes we'll see open circles, it'll be different then. But this time we have a closed circle. That'll give us a bracket, meaning that we include x equals negative 6 as part of the domain. And then as we look along our graph, all the way along that line, that ray, that's not actually a line, all the way along there are no breaks or gaps, and it continues all the way with that arrow going to the right, indicating that it goes all the way over until positive infinity. And larger and larger x values. For this one, we'll do the same thing. We're going to look from left to right. So because this has an arrow pointing off to the left over here, that means that it goes forever and ever and ever to the left. A lot of people make a mistake on this one because the arrow is pointing up also. It's pointing left and up. People sometimes think about the up as a positive infinity, but we're only caring about the fact that it goes to the left. To the left is where negative infinity on the x's are. And then we look along the line. There are no breaks or gaps in it, and it ends right over here at an x value of positive 5. Make sure you don't use negative 4, right? Don't use the y value, use the x value. And then we've got a closed endpoint there, which again indicates a bracket. So our domain here is negative infinity to 5. For this next one, we've got 2 endpoints. We don't have arrows on either end. So if we look, the furthest left that this goes, always looking from left to right, the furthest left that it goes is right here at x equals negative 3. So we'll start with negative 3. And because it's a closed endpoint, it will get a bracket. There are no breaks or gaps or discontinuities along this line segment. So we just follow along until we get to the right endpoint. The furthest right it goes is right here at x equals 6. so we'll stop at 6. This time we'll note that this is an open endpoint, which means we don't actually get there. It gets closer and closer and closer to x equals 6, but never actually hits that value of x equals 6. So when it's not a closed endpoint, when it's an open endpoint, it's a parenthesis rather than a bracket. And it's okay to have a bracket on one side and a parenthesis on the other side. That's not a problem at all. So now we've got a slightly different looking graph here. Right? It's going down and back up and down and back up. But we still just have to look at what's going on as we look from left to right. The furthest left that this goes, if you start the origin and look to the left, the furthest left it goes is over here at -7. So that's where we'll start. Because it's an open circle right here, an open endpoint, we'll put a parenthesis. And if we look along this little graph of a bunch of little line segments here, there are no breaks or gaps or discontinuities along the way. It's just continuous all the way through until, well, at the end here, we've got an arrow, right? We've got an arrow down here, which indicates that this thing is going forever to the right. Well, if it's going to go forever to the right, that'd be positive infinity. And so we'll put a parenthesis on infinity because our infinities will always get parentheses. So for this one, it's going to be a little bit different. We've got the furthest left that this goes is over here at -6. So we'll start with -6. And because it's a closed endpoint, we'll put a bracket. And then if we look along here, starting at x equals -6 and going along, when we get to -2, we have an open circle, which tells us that there is a discontinuity or gap in our graph. Right? The point at x equals -2 is not included in our domain. That's what that open circle indicates. So we're going to say from -6 to -2, and the open circle indicates a parenthesis. But then there's more stuff after the -2. So what we'll say is we'll put this U-looking symbol, which means union. Okay? And then we will pick back up again with -2 with a parenthesis and follow along, and it's continuous everywhere after that until we get to this open endpoint of +6, which will have a parenthesis. And so this is telling us that the domain goes from -6 to 6, but it doesn't include the point at -2 because we had an open circle there. There's a bracket on -6 because it's a closed endpoint, and a parenthesis on +6 because it's an open endpoint. And then we've got the break there at -2. All right, for this one, we're again, just like all of them, going to look from left to right. And this is the type where it's going really steeply up, but still to the left, where people often make the mistake of saying, oh, it's infinity here, because this is going up to positive infinity. But just because it's going up doesn't matter to us when we talk about the domain. We're talking about left and right. Right? So is it going to the left forever? Yeah, fairly slowly. It's going up more than it's going to the left, but it's still going to the left forever because of that arrow. So to the left is always negative infinity. And then if we follow along all the way until we get to -1, this thing is continuous. So from negative infinity to -1, but at -1 we have a break in it. And so we have to decide if it needs a parenthesis or if it needs a bracket. And because it's a closed endpoint, we need to put a bracket. Anytime you have a gap, you'll put the U, meaning union, and then you'll pick right back up where you left off. So this time, we can't start back up at -1 because all in this space right here, there's no portion of our graph. Our graph doesn't start back up again until right here when x is 0. So we'll start at 0 with a parenthesis because it's an open circle. And then it's continuous all along the rest of the way until we get to 5. So from 0 to 5. And the 5 will again have a parenthesis because of the open endpoint. This is the last one we're going to do. It's got quite a few things going on here. Okay. So let's look at the furthest left that this goes. So the furthest left that this goes is over here at -6. So we'll start with a parenthesis with -6. And as we go along here, everything between -6 and -4 is included. But right here at -4, it looks like we should have a discontinuity. I mean, we have a discontinuity, but it looks like we should have a break in our domain, right, where we should not include -4. But if we look up here, there's actually a closed endpoint at -4 also. So we don't actually have to exclude -4 from our domain. We can just continue straight through because we've included all the numbers up to -4. Then we didn't have -4 at this point, but at this point up here we did. So we've included everything up to -4. Then we've included -4 with this endpoint. And then we've continued along our graph until we get to x equals 2. At x equals 2, we have an open circle, which means a parenthesis, and there's no other point at x equals 2. So we have to indicate that there's a break in our domain using the u, and then we don't pick back up again until after this little gap at x equals 3. So we'll put a 3, and that 3 is going to have a bracket because it's a closed endpoint here. And then our graph goes forever up and to the right. The up part doesn't really matter. It's the part about it going to the right that does matter. To the right is positive infinity, which always gets a parenthesis. And that is how we find domain given the graph of a function.